So here we go. Our topic is going to be graphing exponential functions. So graphing exponential functions. And today is the 5th. And it's a little bit challenging to write when your hands are that cold. So if you need gloves tomorrow, feel free to do that. All right. So exponential functions are defined by an equation of the form. Does anybody remember what the form of an exponential function is from Intro to Physics? And it is possible that the variables that we use here are going to be a little bit different than the variables that you use in your science class, but it should be the exact same form. Does anybody remember? If you don't, that's all right. The form of an exponential function. All right, it is y equals a times b to the x power. Does that look familiar? No? For some people, no? No? And again, like I said, it might have been different variables. The a and the b might be different. That you know, the a and the b might be different from your physics class, but the x and the y should be the same. And that's actually what we're going to put over here in exponential functions. So we're going to say y equals a times b to the x power. All right. And the basics of this are, if you have a value of b, so whatever number has the exponent, if that number is greater than 1, this is what's known as exponential growth. So exponential growth, and if it's something is growing, that means it is increasing. So as you look at the function from left to right, it'll end up going in an upward direction. So that would be increasing. And it says if the value of b is less than 1, but still greater than 0, that's what this means. So basically, if b is in between 0 and 1, so if it's like a fraction that's less than 1, but still greater than 0, that would be exponential decay. What's up? I know it's really cold here. It's going to be cold tomorrow as well. So if you need to bundle up, feel free to, like I said, if you want to, I actually might be wearing gloves tomorrow during first period because my hands are freezing. So we got function is exponential decay, and it is decreasing. All right. So that's what we're dealing with there. With exponential decay, has anybody here in a science class ever talked about like radioactivity and half-life? Anybody ever? Yeah, that would be an example of exponential decay. And exponential growth, oftentimes population is growing exponentially. Like the population of Earth continues to grow at a pretty rapid rate. And so this last word here is what is called an asymptote. Anybody heard that word before? An asymptote? No? All right. What that means is it is a line, and it's kind of a funky word, but it's a pretty simple concept. It's a line which the graph gets close to, but never touches or crosses. The graph gets close to, but never touches / crosses. So it'll get super close to that particular number, but it will never actually equal that number or cross over that number. I guess the example would be like a half-life, right? Radioactive material will always be radioactive, but over time it gets less radioactive to the point where it's not even dangerous anymore. But it'll never be 0 for radioactivity. It'll just get closer and closer to 0. It's like the idea if you cut something in half, you always have half of what was left, right? which means that you can always keep cutting that thing in half, which means it'll never be 0. It'll just be really, really tiny. Because if you have something, then you can cut that thing in half and so forth and so forth. And so that would be the idea of an asymptote, because it gets super, super close to that value, but it never actually reaches that value or crosses that value. All right, so today we are going to be graphing these either exponential growth or exponential decay graphs. And there's only 6 of them. But like I said, the really important thing today, honestly, is going to be using your calculator correctly. So everybody needs a calculator in front of them. And if it's a little bit different than this one, that's okay. Yours will probably work similarly to this. If it doesn't, let me know. I can help you out. So let's go ahead and get started. It says classify, the directions here, classify as an exponential growth or decay, create a table of values. So that's going to be the big part with the calculator. And then graph, and then identify the key characteristics. So the first thing we're going to do is we are going to classify this as exponential growth or decay. And so we're saying here that if the value of b, which is the number that has the exponent, so if the number that has the exponent is greater than 1, that would be exponential growth. And so on problem number 1, the value of b is the number with the exponent, so that's 2. 2 is greater than 1, therefore that's exponential growth. We're going to answer all of these other questions, domain, range, y-intercept, and asymptote. We will answer those after we graph this. And then we need to actually choose values for x, because if we're figuring out x, y coordinates, that's what we need in order to graph, we need to choose values for x and then get values for y. Based on these types of graphs, does anybody know, generally speaking, what numbers we use on just a generic graph around, kind of around the point 0 on the graph? If you don't, that's fine. I'll tell you what they are. But all right, so we're going to use 5 numbers. Generally speaking, if you don't have a context, basically if there's no like word problem attached to this, and you don't know what numbers for x to use, the numbers for x that you generally should use are, we'll set up an xy table here. The 5 numbers we're going to use for x are -2, -1, 0, 1, and 2. That'll give us a good picture of what this graph looks like. And it's all going to be centered around the middle of the graph. And so those are the 5 values that we're going to use, I think, on every single one of these graphs today. Yeah. So just choose those, use those 5 numbers for x every single time, -2, -1, 0, 1, and 2. That'll give us everything right around the y-axis in the middle. And then we can graph it from there. So at this point, it's time to complete the table of values. So on this first one, get your calculator ready. And let's see, Justin, do you have a calculator? Yeah. Yeah? All right. Like one of these? No, okay. I'll get you one of these. All right, so first of all, we're gonna go with 2 to the -2 power. And so pretty much everything that we do calculation-wise today is gonna be on our calculator. So we're gonna type in 2, and then the exponent button is the up arrow diagonal up from the 7. We're gonna have to get really familiar with that button there today. So 2 to the, and then just type in -2, and it says 1/4. Now, in terms of graphing, it's oftentimes easier to use a decimal when you're actually graphing this. So if yours is showing 1/4, that's fine. But if you want to convert that from your fraction to a decimal, which is what we're going to do today, there's this little button above enter with the left-right arrows. Push that button and it'll convert it to a decimal. What's that? So we type in 2 and then the exponent button, and then the negative button down here by the decimal, and then 2. So yeah, yours is looking a little bit different than mine because you're classic math, right? Okay. Yeah. And then we get from 1.5. All right. Good morning. Okay. Quick show of hands. I just wanted to double check because we had a little mode issue. When you hit the exponent button, did anybody get the up arrow instead of the blinking box? Like when you typed in like that, did you get this button? Did you get that symbol instead of a blinking box? Anybody else? Okay. If not, if you got this, we need to change the mode. If you didn't get this, if you got that with the blinking box, that's a good thing. That's what we're going for. Okay. So we said 0.25. So 0.25. All right. Then we're going to do 2 to the negative 1 power. So it's the exact same thing. And then we type in 2 with the up arrow and then to the negative 1 power. And we hit enter. And that's 1/2, which is 0.5. Yep. And again, if you want to change from a fraction to a decimal, which is probably better to do with when you're graphing, it's just the button right above enter. That'll convert that to a decimal. So we got 0.5. And then these last two, if you want to use the last three, you can use a calculator if you want, but we probably don't need to because anything to the 0 power is what? 1. And then 2 to the first power is just 2. And 2 to the second power is 2 times 2, which is 4. So if you want to use your calculator for those other ones, you're welcome to do that. And I'm going to go ahead and just draw a line in between each one just so I don't get confused as to which ones match up. So there's our table of values. And now we're going to go ahead and graph these. So a lot of this is going to be approximations when we're putting these points on our graph because these are whole numbers that we see on our graph here. So if we go to -2 on the x-axis and then up 0.25, that'll be right about there. Just a little bit up from the x-axis itself. It's about 1/4 of the way up, and because these graphs are really small, this is definitely going to be an approximation that we're working on. And then -1.5 would be -1 and then halfway in between 0 and 1, which is right there. And then we have the point 0.01, so that's on the y-axis right here. I should probably be using red just to make it look a little bit clearer, so I'll start doing that after this one. And then 1, 2, so over 1 and up 2. And then the 0.24, so that's over 2, and then 1, 2, 3, 4, right there. Just like that. Yeah, I can zoom in for sure. I know these graphs are really tiny. Okay. All right. So that's our first one there. And we could go, I think there might be room for one more if you say to the third power, 2 to the third power would be 8. So we could put that point on here as well, just to give us another point up that way. So if we go over 3 and 1, 2, 3, 4, 5, 6, 7, 8, that's this one right here. Now you don't necessarily have to put that on your table, but getting more points is always, it's never a bad thing to have additional points. So you can see that this ends up kind of curving upward, right? And the idea here is that this graph will continue on upward in this direction forever. It'll keep going, but it'll just keep getting steeper and steeper. But as we come back down this way, this graph is never actually going to hit 0. It'll never actually be equal to 0 along the x-axis. It'll get super, super close to it. That's the idea of that asymptote line that we were talking about. It'll get super close to it, but it'll never actually reach it. So you're going to draw a smooth curve through the points that you have on your paper. That's what an exponential growth would look like. And again, I know you've probably seen this in your science class already. So I'm hoping that this is going to be a review for most everyone here. All right. Once we have that, we're going to move on to the key characteristics over to the right, starting with domain. Domain, just as a reminder, domain are x values. And the range, those are your y values. So all possible x values would be the domain, all possible y values are the range. This is something that we saw back during, gosh, I want to say the beginning of second trimester. So this graph goes in the negative direction forever on the x-axis. So these are the x values. And on the y values, it actually continues forever as well. It keeps going to the right. It just happens more slowly over time. So it's going to keep going and keep going and keep going. So that means that every number for x is a possibility. Does anybody remember what we say when every single number is an option for the domain? It's the idea of infinite solutions, but it's the kind of domain way of writing that. And the way that we wrote that was all real numbers, which is exactly the same thing as infinite solutions. We just write it as all real numbers, which basically means any number we could possibly think of works for the domain here. It will be part of this graph. Now for the range, it's not quite the same thing because even though it gets infinitely large, go ahead and take one of those and all right. Even though it gets infinitely tall, it stops. It will get close to 0 on the y-axis, but it'll never actually reach 0. And so the range, the possible y values, are all values of y that are greater than 0. So the range, we're going to say y is greater than 0, because every y value will be more than 0, but it'll never be equal to or less than 0. So everything that is above 0 on the y-axis is a possible value for y. The next thing is the Y-intercept, that's something that we've worked a lot with. It's where the line crosses the y-axis. So where does this line cross the y-axis? What's our Y-intercept here? It's the point where x equals 0. So you can actually use your table for this. It's this one right here, 0, 1. Anytime x is 0, the y value is the y-intercept. So the y-intercept is the point 0, 1. And then the asymptote is essentially whatever is equal to the smallest value or the largest value, depending on if it's growth or decay. Actually, no, smallest value is either way. It's equal to the smallest value for y. So the asymptote is at y equals 0. So your asymptote and your range are always going to be very closely related. The only difference is it's an inequality for the range and it's an equality. It's an equal sign for the asymptote. So the asymptote is at y equals 0 because it will get infinitely close to 0, but it'll never actually reach 0. And then all of the range values have to be greater than 0. So that's what we're going to be doing for these problems. We'll be able to speed up our process a little bit as we go through this. And we've got 5 more to deal with. All right, go ahead and take one of those and a calculator. All right. So let's move on down, take a look at number 2. So this one says y equals 1/4 to the x power. And if we go back to the beginning to figure out if this is going to be growth or decay, we said that the value of b, the number that has the exponent, if it's greater than 1, that means it's exponential growth. If that value is greater than 0 but still less than 1, that would be exponential decay. And so the value on number 2 with the exponent is 1/4. And so this is definitely less than 1, but it's still greater than 0. So on number 2, we're dealing with exponential decay. Problem number 2 is decay. And after that, we're going to make our table of values. So we're going to use the same 5 values at x. We're going to use -2, -1, 0, 1, and 2. And we're going to type into our calculator exactly as this shows here, putting our 1/4 inside parentheses. So first thing we need to do is open up a set of parentheses that's right above the 8 right here. And then get your fraction going. So that's the n over d button right here. Push that button. And when you do that, you should have a flashing fraction. And the fraction we are using is 1/4. So we're going to do 1. To get to the bottom, you're going to push the down arrow over here on this little directional pad. So down, and then 4. To close the parentheses, though, you can't close the parentheses yet. We have to push the right arrow to get over to the side of our fraction. So if you push the right arrow, there it is. So now it's flashing in the right spot. So close your parentheses. And then we're going to raise that to the -2 power. So again, the up arrow right here. And then -2. So that gives us 16. So y to the -2 power is equal to, or sorry, 1/4 to the -2 power is 16. All right, then we're going to do the same thing, but we're going to go to the -1 power next. So here we go. Open up set of parentheses, fraction, 1/4 over, close the parentheses, power, -1, and the answer is 4. So 1/4 to the -1 power is 4. 1/4 to the 0 power, anything to the 0 power for that matter, is 1. So 0, 1. 1/4 to the first power is 1/4, which is 0.25. 0.25. And then the last one, use the calculator for this one, 1/4 to the second power is 1/16. But as a decimal, the little left-right arrow above the enter sign right here, that'll convert to a decimal, which gives us 0.0625. So that is our final value there, 0.625. So we've got our 5 values for y with our values for x. All right. Now, -216, so far as I know, doesn't actually fit on this graph. So we'll just have to imagine it somewhere up here. How high does this go? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that'll be, I don't know, somewhere up here. I'm just going to go ahead and make a little point up here above the graph a bit, just to get an idea about where that might be, even though it's not, doesn't actually fit on there. And then we've got -1, 4, so -1, and then 1, 2, 3, up 4 right there. And then we have the point 0, 1 right here. And then 1.25, so that's going to be, again, pretty close to the y-axis on that one. And then 0.0625, that's essentially on the y-axis, or the x-axis at that point. And so what we need to do for this one is, again, just draw your line through as smooth of a curve as you can make through those 5 points. So I'm all the way up here, kind of coming down. And it curves down. And basically just ends up running pretty much alongside the x-axis. So there's our graph for problem number 2. And the domain, by the way, the domain of any exponential growth or decay is going to be all real numbers. So that's going to be, you can pretty much just write all real numbers for domain anytime you have the domain of an exponential growth, or in this case, exponential decay. This one is decay because as you go from left to right, it's decreasing. The first one is growth because as you went from left to right, it was increasing. So they look a little bit different. the range on this one is the same as the range from the first one. Because again, the y values get closer and closer to 0, but never actually equal 0. So that's y is greater than 0. The y-intercept is actually the same as the first one as well. You go back over to your table, where x is 0, y is 1. So 0, anytime x is 0, the y value is your y-intercept. So again, 0, 1 for the y-intercept. And then our asymptote is y equals 0, because the asymptote is always going to be the same value as the range. We're just going to use an equal sign instead of an inequality symbol. That's our answer for number 2. All right. Is this looking familiar-ish, at least the shapes of the graph? Maybe some of this information over here isn't necessarily what you've done before, but it's all good information to have on these types of graphs. All right, are there questions before we look at page 2? We got 4 more problems to look at. And we're going to start picking up the pace a little bit as well. What's that? So anytime x is 0, the y value with that is the y-intercept. So it's going to be 0, 1. Yeah. All right. Does anybody need more time on problem number 2 before we look at the third one? All right, like I said, I'm going to start speeding things up a little bit with number 3. So here we go. On number 3, first thing we need to do is identify if this is growth or decay. And the way that you do that is the number with the exponent is what we're looking at. So this time it's 3. 3 has the exponent. If that number is greater than 1, then we're looking at growth. 3 is greater than 1. So this one is exponential growth. From there, we're going to go ahead and make our table of values using our 5 numbers for x. So that would be -2, -1, 0, 1, and 2. So we got our table, -2, -1, 0, 1, and 2. All right, now we're going to start plugging in. And we've got 3 to the x power minus 1. So our first number is going to be 3 to the -2 power. When you subtract 1, don't just type in -1. You have to push the right arrow over on this little directional pad in order to get the flashing square off of the exponent, because we don't want it up with the exponent. So you're going to do -1 after that. So 3 to the -2 power minus 1 says -8/9. We're going to go ahead and convert that to a decimal, which is -0.8 repeating. So -0.8 repeating. So almost at -1, but not quite. And then we're going to go through and do the rest of these. So 3 to the -1 power minus 1. That's -2/3, which would be -0.6 repeating. The next one, 3 to the 0 power is 1, and 1 minus 1 is 0. So that's the 0.00. Next one, 3 to the first power is 3. 3 minus 1 is 2. You can use your calculator if you want to, or if you just want to go with mental math on these last ones, that's fine. Last one here, 3 squared. 3 times 3 is 9. 9 minus 1 is 8. So we've got -2, -0.8 repeated, -1, -0.6 repeated, 0, 0, 1, 2, 2, 8. So we'll go ahead and graph those. So -2, -0.8 repeated, that's almost -1. So put a dot right there. So that's our first point there, -2, -0.8. Then -1, -0.6, that's about halfway in between 0 and -1, a little bit more than that. So as best as you can, a little bit more than halfway in between 0 and -1. And then we've got the 0.00, and then 1, 2, and then 2, 8. So those are the points that we're looking at right there. So this time, our asymptote isn't at 0. In fact, sometimes we can kind of see where that's going to be, right? Where is that where is this going to end up getting close to but never crossing? What is that y value right here? -1, yeah. So basically our asymptote is going to be basically where it starts to straighten out horizontally. That is going to be our line that we're not going to end up crossing. So we'll curve it around and basically get really close to that line, but never actually touch that line or intersect with that line. So that's our graph there for problem number 3. So our domain, just like our domain for every other one that we've got for exponential growth or decay, the domain is going to be all real numbers. And this time, the range isn't going to be y is greater than 0. It'll be y is greater than this one here, which would be -1. Because this one actually drops below the x-axis. So that range would be y is greater than -1. The y-intercept this time is where x equals 0, and then that was y equals 0 as well. So that's just the point 0, 0. It's the origin of the graph. You can see that, y-intercept 0, 0. And the asymptote is the same as the minimum value for the range, which is -1. So we're going to say y equals -1. All right. Go ahead and do a few more. Number 4. Again, like I said, I'm going to be moving pretty quickly from here on out. So number 4, the value with x, the value with the exponents. Is that going to be growth or decay? That's going to be decay because 1/3 has the exponent and 1/3 is less than 1 but still greater than 0. So number 4 is decay. All right. Then we're going to set up our table of values. X, y. With our 5 numbers, -2, -1, 0, 1, and 2. And we're going to go ahead and start plugging things in. So parentheses, fraction, 1/3. Close the parentheses to the -2 power. Go over, and then +4. 13. So -2, 13. Make sure that you're getting this on your calculator. If you're having a hard time making sure that this ends up showing you an answer of 13, let me know. I'm happy to help you out because, again, using the calculator correctly is maybe the most important part of what we're doing today. So 13 is what we have for x equals -2. For x equals -1, the fraction button is the n/d right here. So you open your parenthesis, hit your fraction button, and then type in 1, and then you're going to use this little directional oval on the right side. So when you type in the 1, push the down button, and then 3. And once you hit the 3, you're going to push over to the right. Push this button once you have your denominator, and then that'll get your flashing square off to the side of the fraction like that. What's up? Go ahead, yeah. And then close your parentheses. And we're going to do -1 this time. And then over again, +4 is 7. So -2, 13, -1, 7. 0, anything to the 0 power is 1, and 1 + 4 is 4, so that's 0, 4. All right, and then we're going to do a couple more here. So we've got 1/3. Oops, 1/3. That's to the first power. So you can just do 1/3 + 4. 1/3 to the first power is 1/3 + 4. 13/3, which as a decimal is 4.3 repeating. 4 and 1/3. And then the last one to the second power, and then +4. 37/9, which is 4.1 repeating. All right. Yes. Yeah. You're right. Yeah, sorry, it's not 0, it's 1 plus 4 is 5. Yes, thank you. So yeah, to the 0 power is 1. I, for some reason, went with 0. You're correct. Yes, that is 5. Otherwise, that would not have looked right. Thank you. All right. So our 5 points, we'll go ahead and graph these. -2, 13. Again, 13 doesn't really appear on this graph in terms of the y values, but if we go with -2, -13 is going to be somewhere about here. So I always do, if it goes above it, I just kind of estimate where that's going to be because most of these points on here are estimations anyway. And so it's good just to have that guide as we go through this. -1 up 7. So here's 10, 9, 8, here's 7. And then 0, 5, which is here. And then we've got 1 and then 4.3. So a little bit above 4, about there. And then we've got 2 and 4.1, which is just above 4. So we have our exponential decay here. And it's coming down, and it ends up turning. About like that. And this will be the last one that we do. So we've got our domain of all real numbers. And our range this time. What is our range this time? So the last one was y is greater than -1. The first two were y is greater than 0. What do we have this time? They're all going to be y, for these types of problems anyway, it's going to be y is greater than. What is it greater than this time? 4, yeah. The lowest point on the y-axis this time is 4, so y is greater than 4. And the y-intercept is at the point 0, 5. And the asymptote is always going to be equal to the smallest value for the range, so that's going to be y equals 4. All right, we'll leave 5 and 6 blank because I'd like you to get started on your assignment. Make sure you've got time to work on that. So that is all we have.